Next, let's look at combining transformations. In the first example, we have f of x is equal to the absolute value of x plus 2, and then we're going to subtract 4 from that. The first order of business is we want to think about what the parent function is. In this case, the parent function is y equals the absolute value of x. We already know that this graph has a V shape to it. Well, I see two transformations here. One of them is that we're adding 2 to x. Adding 2 to x is going to create a horizontal translation 2 units to the left. Secondly, I see that we're subtracting 4, but we're subtracting 4 from the entire parent function. That's going to create a vertical translation 4 units down. Now I'm going to try to do this all in one graph. I know in the previous video we had different graphs for the different steps, but let's try to do all the work in one graph. First, I'm going to graph the parent function, y equals the absolute value of x. It looks something like this. Next, we're going to take this graph and we're going to move everything to the left 2 units. So instead of having this vertex here at the origin, everything's going to move over 2 units. From here, we're going to go right through here. And then to the right, we're going to go right through here. Maybe off just a tad. Finally, from the green graph, we're going to move everything down 4 units. So you see this point at -2, 0? It's going to move down 1, 2, 3, 4 units where I just put down that blue dot. And now everything else is going to move down with it. And so we're going to go right through here. And same thing on the other side. So the blue graph is going to be the final graph. Now my left branch there got a little bit off. I'm a little neurotic, so I think I want to fix that. Neurotic's not the right word. I'm a little picky. Let's say I'm picky. So 1, 2, 3, 4 down. And let me just put some guiding points here. Basically, these branches have a slope of +1 or -1. So I can pretty quickly get some guiding points. That makes me feel a lot better. Okay, in the next example, we have f of x is equal to the quantity x minus 1 squared plus 2. First, let's identify our parent function, which in this case is the square function, y is equal to x squared. I see two transformations here. First of all, we're subtracting 1 from x. Subtracting 1 from the input x is going to create a vertical translation. And in this case, we're going to move 1 unit to the right. Then we're going to add 2, but we're adding 2 to the entire parent function. And so this is going to create a vertical translation 2 units up. So let's start with our parent function, y equals x squared. I have a point there, 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 and there. So here's my first branch for the parent function. Then I'm going to have a point here, here, and here on the left. So that branch will complete the parent function's graph. Now everything's going to move to the right 1 unit. So every dot that I had there as my guiding points, All of them are going to move to the right 1 unit. So here's our intermediate graph. And now finally everything has to move up 2 units. So again, I'm going to take all those green guiding points and all of those are going to move up 2 units. Some of them are going to fall a little bit off the graph here. I think there's one there that I didn't plop down correctly. That one there. So green dots, all of them 2 units up. All right, so finally here in blue would be my final graph. We started with the parent graph in red, then we moved everything to the right 1 unit in green, and then from there we moved everything up 2 units in blue. Let's look at the next examples. It says the graph of the function f is shown below. We have to graph the function g. Now this is a little different because instead of having a rule for f, we have its graph. But it's just a matter of knowing what to do with that graph, how to manipulate it. So let's see. In this first example, f has this kind of curve here in quadrants 1 and 3. And g of x is obtained by adding 1 to the input. Adding 1 to x is going to move the entire graph left 1 unit. So if I take all of these points and just move them 1 unit to the left, I'll have a pretty good idea as to what the new graph is going to look like. So on the left, we're going to be going through here. There we go. Everything moved over to the left 1 unit. In the last graph, we have the same f function, but we have 2 transformations. The first one we've already taken care of. That's going to move the graph left 1 unit. The next is going to be a vertical translation because we're subtracting 2 from the entire function. That's going to bring the graph 2 units down. So I'm going to go back to the first graph because I already have the intermediate step in blue. So if I go ahead and use what I've done and move everything down 2 units, each point is going to move down 2 units. All those blue points are going to move down 2 units. So now if I connect those guiding points with a curve, I will have the function g of x.